In 2026, the phrase AI agent is everywhere. Every product claims to be one. Every startup says it is building one. But ask most people to explain the actual difference between an AI agent and a chatbot with an API attached, and they cannot. That gap matters. Build on a definition you do not understand, and every architectural decision that follows is shaky. In this video, I will give you the verified, precise characterization of what an AI agent actually is in 2026. The 4 components every real agent must have, the cycle that makes it work, and 3 real-world deployments already producing measurable results. This is video 1 in the AiMineLab AI Agent Series. By the end of the full series, you will be able to build one using only free tools. Start with the formula nobody explains clearly. The clearest definition in the industry comes from Lilian Weng at OpenAI. Her 2023 technical post became the most cited reference on agent architecture in the field. Her formula? Agent equals LLM plus memory, plus planning, plus tool use. Simple on the surface, but each of those 4 terms has a precise meaning that separates a genuine agent from a product that merely uses the word. The formal description from AI Systems Research: an agent is a system running a continuous cycle. Perceive: input arrives from the world. A user message, a file, a database result, an API response. Reason: the language model thinks through what to do next, given the goal, the available capabilities, and whatever it remembers. Act: a real action follows, not just a text response. An API call, a file write, code execution, an email sent. Observe: the result of that action comes back. The system sees what happened. The cycle begins again. This process runs until the task is finished, or the system determines it cannot be completed. That word, cycle, is the architectural dividing line. A chatbot does not cycle. It receives a message, generates a response, and stops. One call, done. An agent continues. It acts, observes the outcome, updates its understanding, and tries the next step. That is the fundamental difference in how these 2 systems are built. One concrete example makes this clear. The request: cancel my annual plan and refund the unused months. The chatbot: a chatbot receives the request. The language model generates a polite reply, probably suggesting you visit the billing page or contact support. One model call. The system cannot take any action on your behalf. It is a text generator with a system prompt. The agent: an agent receives the same request and reasons through what needs to happen. Access the account, check the billing plan, calculate the refund, trigger the cancellation, confirm completion. First, it calls the account lookup tool. Account data returns. Next, it calls the billing calculator. The refund amount is $47.50. Then it calls the cancellation endpoint. Confirmation arrives. Finally, the response is written. Your plan has been canceled, and a refund of $47.50 will appear within 3 to 5 days. Identical request. Completely different result. The chatbot described what to do. The agent did it. Now the architecture. 4 components. Every genuine agent has all 4. Remove one, and what remains is something less. Component 1, LLM core, the reasoning engine. The language model is the reasoning core. It receives the goal, the available integrations, relevant memory, and the results of previous actions, and decides what to do next. In 2026, this core can be Claude Opus 4.7, GPT 5.5, Gemini 3.1 Pro, or a local open source model like Llama or Qwen running on your own machine. The architecture is model agnostic. The same framework works with any language model you choose. Worth noting, the LLM is not the agent. It is the brain inside a larger system. The agent is everything built around it. For tool calling specifically, Claude Opus 4.7 currently leads the MCP Atlas benchmark at 77% accuracy. Tool calling reliability is one of the most important factors when selecting a model for agent work. Component 2, memory, what persists across time. Memory is the most underestimated component. Without it, the system forgets everything the moment a session ends. 4 types are defined in the Koala framework from Princeton University. In context memory, the active context window, everything visible right now. Temporary, limited by the model's maximum length. Episodic memory, a record of past interactions and outcomes. What happened before? Which actions succeeded and which failed? Stored in a vector database and retrieved by semantic similarity. Semantic memory, factual knowledge, company policies, product information, rules the system needs when reasoning. The stable knowledge base. Procedural memory, behavioral patterns and workflows, how to complete recurring tasks, skills the system has been given or has learned. In production today, Mem0 is the most mature mature open-source memory layer for agents. It handles all 4 types and connects to every major framework. Component 3. Tool use. Real-world capabilities. Capabilities are what allow the system to affect the real world. Without them, it can only think and respond. With them, it acts. Each capability is defined by a name, a description, and an input format. The language model reads those descriptions and selects which one to invoke, with what inputs, based on its reasoning at that moment. Common integrations in 2026. Web search, code execution, file system access, database queries, external API calls, email and calendar, browser automation, and communication with other agents through the A2A protocol. This is where MCP, the Model Context Protocol from our previous video, becomes essential. MCP standardizes how integrations are defined and accessed. Any agent with MCP support can immediately reach any of the 17,000 plus tools in the public registry. The breadth of available integrations determines what an agent can do. The quality of the language model determines how reliably it uses them. Component 4. Planning, the orchestration layer. Planning is how the system converts a high-level goal into executable steps. In simpler designs, planning is embedded in the cycle. The model reasons about the next action at each step as it runs. In more capable designs, planning is explicit. A full sequence is drafted first, then executed step by step, with the plan updated whenever an action returns an unexpected result. This layer also handles failures. A tool returns an error. A search comes back empty. An API times out. The planning layer decides whether to retry, take an alternative route, or escalate to a human reviewer. Here is where the real intelligence sits. 2 systems with identical language models and identical integrations will perform very differently depending on how planning is designed. Now the practical mechanics. The pattern used inside most agents is called REACT, short for Reasoning and Acting. Published in a 2022 paper by Shunyu Yao and collaborators at Princeton and Google, it has since been adopted as the default pattern in LangChain, LangGraph, the OpenAI Agents SDK, and PRAO AI. Think of a detective working a case. The question, was the suspect home that night? Thought, I should check with the neighbor. Action, calls the neighbor. Observation, the neighbor says they left at 8 in the evening. Thought, I need to verify that against the building cameras. Action, requests the camera logs. Observation, footage confirms departure at 4 minutes past 8. Thought, enough information. The suspect was not home. Think, act, observe. Repeated until the case is resolved. An agent follows the same sequence. The thoughts are generated by the language model. The actions are calls to real systems. Thought, the user wants the current price of Apple stock. Real-time data is not in my training. I need to search. Action, web search. Apple stock price today. Observation, current price is $214.37. Thought, I have what I need. Response, Apple is currently trading at $214.37. 3 things make this pattern work reliably. First, reasoning is written out before each action. This forces the model to think rather than pattern match and makes the sequence auditable. Second, the process runs until the task is actually done, not until a response is generated, until the goal is achieved. Third, each action is grounded in a real observation. The system does not invent tool results. It calls the integration and works with what comes back. This is not theoretical. AI agents are running in enterprise production at scale in 2026. Here are numbers from verified sources. Gartner's official forecast, published in August 2025, 40% of enterprise applications will embed task-specific AI agents by end of 2026, up from under 5% in 2025, an 8-fold increase in 12 months. The global market for AI agent systems reached $7.6 billion in 2025 and is projected to exceed $10.9 billion in 2026. 80% of enterprise applications shipped or updated in the first quarter of 2026 now include at least one embedded agent. Here is the honest number to balance those headlines. Only 31% of enterprises actually have an agent running in production. 79% claim to have adopted them. The gap between announcement and working deployment is where most organizations are right now. 3 verified production examples. Healthcare documentation. Multiple healthcare providers, including those using Mayo Clinic's voice care platform, deployed agents that generate clinical notes automatically after consultations. Physicians reported 42% less time spent on documentation, a task that previously consumed 1 to 2 hours per shift, now handled without manual input. Supply chain at General Mills. General Mills built an agent that evaluates over 5,000 shipments daily, routing, timing, and supplier reliability, without requiring a human decision on each one. The result since fiscal 2024, over $20 million in verified savings. Exceptions are flagged for human review. Routine decisions run autonomously. Software engineering. Enterprises using Claude Code report agents now handling measurable portions of code review, test generation, and pull request descriptions without human initiation. Claude's Opus 4.7 model leads the SWE Bench Verified benchmark at 87.6%, correctly solving nearly 9 out of 10 real software engineering tasks in independent testing. Anthropic now holds 32% of the enterprise language model API market. Across all three, the pattern is consistent: narrow scope, clear success criteria, the right integrations, human oversight at the edges. Median time to return on investment across enterprise agent deployments, 5.1 months, according to combined BCG and Forrester surveys in 2026. One context worth adding: the EU AI Act becomes enforceable in August 2026. Agents making autonomous decisions in high-risk domains will require documentation, human oversight mechanisms, and audit trails. Worth knowing before you design something for a regulated environment. That is video 1. You now have the verified architecture, the 4 components, the PRAO cycle, the React pattern, and where agents are delivering real results right now. Here is where the series goes from here. Video 2. Choosing the right language model for your agent. Claude versus GPT versus Gemini versus open source local models. An honest benchmark breakdown. Video 3. Tool calling in depth. The most important concept most tutorials skip entirely. Video 4. Memory and RAG for agents. Short-term versus long-term versus external retrieval. Video 5. Framework comparison. LangChain, LangGraph, Crew AI, AutoGen, and N8N, which fits which use case. Video 6. Safety and guardrails. Why most agents fail in production and how to build around it. Video 7. Build your first agent using only free tools, step by step. No code required. Subscribe so each video reaches you when it publishes. Drop a comment below. What would you build if you had a working agent? I read everyone. 2 sentences you can use the next time someone asks what an AI agent is. An AI agent combines a language model with memory, planning, and integrations, running in a continuous cycle until a task is complete. Unlike a chatbot that produces one response and stops, this kind of system takes real actions and adjusts based on what it observes. The 4 components: reasoning core, memory, tool use, and planning. The cycle: perceive, reason, act, observe. The pattern running that cycle: react. Thought, action, observation. From Princeton and Google's 2022 paper. This is AiMineLab. Honest AI education every week. No hype, no paid promotions, just what actually works, verified against real sources. Video 2 is next. See you there.